everybody. Thanks for coming. You guys are the good bunch. You're kind of sticking around for some of the last bits of the day. So welcome to day 3. My name is Brian Lazier. I run product management for a part of our portfolio called Zero Trust Cloud, and we'll cover a lot of these details. But we help customers protect their workloads in cloud as well as the workload traffic, and I'll cover a lot more details about that. But it's an exciting space for us to help customers. Just quick, what folks here who are not familiar with Zscaler? Just curious for those that are not familiar with Zscaler. Here, a couple. Okay, so most of you assume know a little bit about Zscaler. So we'll cover this area around how we're helping customers with their AI development. And I have a little bit of a preamble that just kind of orients you to how we describe some of the capabilities that we support customers, even beyond some of the workload capabilities. To start with, I'll just touch on, this is a key topic around how you transform, and one of them is just around your application transformation. Typically, you're moving, say, from bare metal or VM EC2s, and you're moving into, say, container environments, but you're also leveraging some of those service capabilities for applications like an IaaS or a PaaS. The area that we help customers quite a bit is around the networking side as well as the security piece, and that includes helping kind of rethink some of your basic architectures, especially if you've come from like an on-prem data center environment and you're moving into public cloud. But I'll talk about that articulation and how we're helping provide more direct access to applications and users. And we have terms, things like around the traditional hub and spoke or castle and moat models that we help customers consider for their environments. So we'll talk about how we describe some of the problem statements here. And this kind of describes how you might have your environments today where you kind of centralize a lot of your traffic, your user access. And this would be kind of that castle and moat model where there's a lot of rigidity here, where your access, say, to internet, to SaaS-based applications, they might have to go through a specific location to get out. So this is where you maybe kind of hairpin things back through a data center. The concept of backhauling will come into play here. But the other challenge with this is that once you have maybe a problem in this environment, like let's say you've got a bad actor, you've got malware that surfaces, there's a lot of surface area to deal with, logically. You've got a huge issue in terms of the lateral threats in this type of topology. The other thing about this that we talk a lot about with Zscaler is how we ensure that as traffic needs to hit the wire, how you authenticate, how you identify, and that becomes sort of the key principles to Zero Trust, and doing that for both users and workloads. So if you have kind of a identity-less approach, you might be more kind of a layer 3 model, then that can provide some challenges for you because it makes your environments vulnerable because you don't necessarily know who or what is on your environment or in your networks. So our transformation in this area for both networking and security is how we can help customers shift to the right side image, where we can provide access for users and workloads to wherever that you need to go. And this can be very specific, where we can help, say, if you might have like a Zscaler client connector on your laptops, as an example. So through even those mechanisms, you can provide access to specific applications in, say, specific locations. We provide a lot of authentication methods to ensure that user has the credentials to even go on the network and then access those locations. So things like digest and basic auth, or we now support JSON Web Tokens for workloads and things like that. So those auth, but also the identity pieces come into play, and that enables the image on the right. Now, what's also interesting about this is that if you maybe haven't kept up with Zscaler, we have been expanding use cases quite a bit. And that's noted by how we support beyond the user side, which is the origin of Zscaler, is helping the user cases, providing those Zero Trust. But now it's with branch locations, so factories, remote offices, We even have hardware now, so you can have a CPE box that goes in those locations, and it can provide those identities and authentication mechanisms for traffic that's going outside of your factory branch remote location. We also have agents now, and I'll talk a little bit about that. So that can be applicable to agents that run on your EC2s themselves. We even have support now for container native services like EKS. You can have a presence in that location to provide things like micro-segmentation and kind of micro-flow visibility and controls. And I'll also be touching on most of this conversation over on the upper left there, which is Zero Trust Cloud. And this is helping the customers with workloads in public clouds, as well as data center environments. So those would be considered a private cloud location, and then providing those workloads access to wherever it needs to go. And that's extending in terms of the use cases that I'll talk about too. Cool. All right, so let's get into kind of the meat of it. So this is a topology view of what we'll call it an AI-powered SDLC environment. We're noting here an example that's actually, we have got a couple of customers that are already deployed with this case. They happen to use Cognition. This is using the Devon offering from Cognition. So I'll kind of walk through the case here. You have developers. These are your users that are accessing a prompt coming from the outside, and they're accessing the front end of, in this case, the Devon SaaS offering. There is a back end to this capability. Let me click through here. Let's see here. There we go. Okay. So for this kind of capability, it needs to access, there is a back-end capability for this SaaS offering, but also it needs to get the context to build the application. So that context comes from your applications. In this case, it could be a mix of your private applications. So examples would be like an Artifactory, it could be a Jira, Confluence. So it needs the ability to articulate the context for the build. Like this is an epic, this is a version XYZ, this is a top priority, those kinds of things. And even the back end of the private applications could include things like your database environment. And then the other piece to this is accessing your private applications. So bear with me here. My clicker's a little slow. There we go. Okay. So the access here is getting context from public locations, like a Git, or it could be Stack Overflow, or an Atlassian, or whatever you might have that's in the public environment. This would be outside of your cloud region. So that's the typical lay of the land. And I'll talk about this as we kind of progress through how we support the sort of details of each of those use cases. Now, to start with, so Zero Trust Cloud, which is the area that I help support, this includes two major components. One of them is referred to as the Zero Trust Gateway. And there was a talk yesterday that my manager, Dhaval Sharma, covered. He talked about the Zero Trust Gateway. So this is the ability for customers to secure their workload traffic within cloud environments. So this would be addressing your VPC to VPC traffic that's egressing out through like your internet gateway, but also traffic that might be coming in. So through ingress, but also through bidirectional traffic, say with a direct connect use case. So that's all covered through the Zero Trust Gateway, and I'll expand on that. And this is us managing some back-end infrastructure, so you can just simply apply policies and rules, and you're up and running very quickly. And this is a fairly new offering that is available on AWS now. The other area is called Zscaler microsegmentation. Simple name, pretty easy. It follows microsegmentation principles. This is a host-based agent that runs on VMs and EC2s and also supports container environments. And so this is typically used for crown jewel applications. So you can think of it as being like you have a macro segmentation capability with macro level controls for the gateway, whereas the microsegmentation would provide obviously the micro controls. Now it's micro flows. So we have sort of the hierarchy, if you will, in terms of the visibility and protection. So let's kind of expand into that. I'm going to give you some of the details on Zero Trust Gateway, so you have a little bit more context. So this is a service that Zscaler runs. We manage what's referred to as cloud connectors. Customers can run your own cloud connectors if you wish. But we actually manage those for you if you choose this route. This is a deployment option. The Zero Trust Gateway is actually using Gateway Load Balancer. So your artifact is an endpoint. So it's an endpoint service. It's regional. We do support multi-AZ, so you can apply it across one-to-many AZs, depending upon how many AZs are available in a region. We can expand all those AZs, so it has high levels of resiliency. The mechanism, I'll kind of walk through the use cases, but this first one is that we now support what's referred to as east-west, those lateral traffic use cases. And so your insertion is using cloud-native routes, just as if you're using a lot of the sort of common networking services you're familiar with. So you route that traffic that you want to get inspected, and that goes right to your service endpoint. So in this case, you would be applying it, say, between VPCs, and then you can apply those rules and filterings using that. And then the next use case would be for the egress use case. So traffic that is originated from your cloud region and needs to go out to internet or to a SaaS-based application. And in this case, this is actually using some of the capabilities you're probably familiar with if you're a Zscaler customer. This is now using ZIA, which is Internet Access, or ZPA, which is our private access capabilities. So ZIA you can think of as being a full stack of filtering capabilities. It has sort of traditional firewall mechanisms, like layer 4, has layer 7, has SSL inspection capabilities. We also include data protection in ZIA, so you have full capabilities for protecting the content payload in the traffic egressing out. And this includes even advanced DLP. So you can have like OCR and EDM capable for that. What's unique about this path is that we also enable the private application, or the ZPA. So this enables you to connect your private applications together across regions, across clouds, across your hybrid environments. So if you have an AWS environment and you're connecting that application to, say, a data center you might still maintain, then you can apply that. So ZPA, you can think of it as almost being like a very intelligent L7 type tunnel. So your mechanism for endpoints can be all the way down to a tag. So you can say, like, this tag from AWS, I want to connect to a tag, let's say, in an Azure environment. So you can do very fine-grained controls. We're not big fans of layer 3 routing and VPN. We try to keep it very application-centric. So that would be the mechanism for the private application example up there using ZPA. The next one would be for the gateway also supports the ingress path. So this is your typical, it's an unauthed user, an unauthed workload that's coming into your region environment. So we can now support this use case. And the note here is that this does support the Direct Connect as well as some of the other private connectivity services from the other clouds coming up soon here with ExpressRoute and Interconnect. Sorry, I did mix that up there. So that's the private network traffic would be over a Direct Connect bidirectionally, and then the last one would be your internet access. So this would be your unauthed user or workload coming into your environment. Typically, customers that would have this path, they would have some kind of a CDN. In this case, we're noting the CloudFront that would be in front of your Zero Trust Gateway. So this kind of gives you a lay of the land in terms of the different workload paths that we can address with the service, and it captures the essence of them. We're excited about it because we can help customers with a zero trust approach for all their network paths for workloads. Let's see. Let me highlight the internet case, and I'll give you a couple of topology images for each of these. So let me break this out. So for traffic to internet, so this is that egress case I was referring to. So there are a couple of notables here. We do support, on the left there, the Azure and GCP tags are new. We do support AWS tags for this. So you can think of the tagging mechanism as being your object definition. I'm sure many are familiar with the tag or the cloud metadata as an option for your objects and rules. So this is now available here, where your traffic that's egressing out, you can tie it to a tag. You can even tie it to a cloud-native attribute, like an OS type or an ID. So that aligns you well in terms of it gives you that identity, but it also aligns to maybe some of your teams that we're even more tightly coupled to your DevOps. As they tag that application, your downstream teams on network security can pick that up and now apply that policy to that traffic. Another recent thing actually we did support now is the JOT tokens I mentioned before. So we do support a couple of different auth mechanisms, but the JSON Web Token has been one more recently that customers have been referring us to. We now support. This is more of kind of a workload specific. So as your workload is egressing out, you can do a token tied to that per application and even per session. So it's very, very fine grained. And these are kind of the core principles of Zero Trust that we could provide, which is that identity and auth. And then once it hits what we refer to as the Zero Trust Exchange, so this is a cloud-based service. We've got, I think, well over 150 locations now that continues to grow. They're located all over the world. So this is our, basically that's your inspection engine, is the Zero Trust Exchange. And this is where all the ZIA capabilities I mentioned are inside of that. So you have very high scale support for some of these very complex rules where you don't have to think about resource constraints because it's now a cloud model. So if you had things like TLS rules for a lot of your traffic, that's all done through the Zero Trust Exchange. And other things like if you're doing full content payload inspection or data protection, that's all inside of the Zero Trust Exchange. Cool. And actually, just as you know, the image in the upper right will kind of give you a guide for how our capabilities will align with the broader use case that I shared at the beginning with the Cognition Devon case. So this will be the internet one first. So simple view of what it looks like in your environments. You'll notice that there's a couple of accounts here. So this is a region view. We're picking on US West 1 here. So the right side reflects the Zscaler account where we're managing your infrastructure. These are referred to as cloud connectors. These are EC2 based, and these horizontally scale because we're using the gateway load balancer for that. And this scales to cloud speed. So we're basically bottlenecked by the adjacencies. Like if you're attaching your account, say your VPC, this would be like a services VPC where you'd have like your endpoint. And so you're bottlenecked by the attachment to Transit Gateway or NAT Gateway, basically the adjacency services around it. So we can achieve into the 40 to 50 gigabit per second range. The couple other things I'll note here is that you'll see the endpoint that is in the customer environment. So that's what you would direct your traffic to using the cloud native route, and that becomes your insertion point for inspection. And that traffic would be automatically redirected over to the Zscaler managed connectors, and then traffic is then sent to the Trust Exchange. And remember, this is the internet egress, so it's following, you can think of it as like natural path. The traffic is going out, it's going out to internet, and on its way, it's getting inspected by the Zero Trust Exchange. Okay? And we'll use the customer image on the left in the rest of the pictures. So you'll see a couple of those VPCs there. Great. So we'll move on to the ingress use case. This is new. We actually just announced ingress support last month in November. So a lot of our Zero Trust path has been very focused on egress, which is arguably a pretty important path for customers to make sure that you track that traffic, you apply the appropriate segmentation, the security controls and filtering. But the signal has been, can you give us more from customers? Can you enable more capabilities and essentially cover all the workload paths that we have? In other words, our traffic for our workloads is more than just going out. We have traffic cases that come in from internet, and they may not be zero trustable. So how do we support that? And so we now include that. It's now available in our product. And in this case, we support ingress from internet, but also ingress as well as egress out over Direct Connect. So you can think of your kind of north-south type services or north-south access can be addressed by Zscaler now. This is done actually on the gateway. So what's unique about these additional paths is that we don't have to rely on our Zero Trust Cloud or Zero Trust Exchange, which is kind of upstream, if you will. It's outside of the region. In this case, it's actually all local. So you can think of your gateway, that the data plane is actually the gateway for this use case. So your traffic comes through. I'll show you the image in a second. And the enforcement is all done on the gateway. So it's all within your region. And these rules are what we call essential rules. So these are stateful layer 4. And we do include the ability to use the cloud metadata as your objects. So you can use those tags or those attributes to define your destination, in this case, as it's coming in. Okay. And then here's we'll kind of walk through this image a little bit. It's, again, a region view. You'll note that we have the Zscaler managed account at the bottom. This is, by the way, a single tenant service. So we have a dedicated set of infrastructure that our SREs from Zscaler manage, and the customer environment at the top, we carry over the same image with the two VPCs. So here they have access from internet. So there could be a case where maybe you have a partner that needs to come into your environment. It could be like a completely unauth case where you may not even know the source IPs, but you can also support that with this capability. So if you had any kind of hosted applications. And then the other case here is with a direct connect, where that's connected ultimately through your transit gateway. And then again, using the cloud native routes, you're just routing it to your services or security VPC where you'd have the endpoint service running there. And then you can protect that traffic coming in, as well as the egress for the direct connect use case. All right. And then we'll jump into the east-west traffic. So east-west, it can be pretty daunting, a lot of traffic. It depends on your environments, but obviously east-west can be quite a bit. You're not WAN bottlenecked. We are seeing a lot of customers using this capability. Use cases are typically shared services. So we have customers that dedicate a VPC, and they enable their other VPCs, like their tenants, to access those applications. So you might be running a similar model where you have tenants or opcos that are dedicated by VPC, and they need to access certain applications that you manage in another VPC. So a lot of chattiness in that case. Other use case for east-west would be multi-tier applications. So if you have your, say, 3-tier application and the DMARCs are subnets or VPCs, then you'll obviously have the communication between those tiers, and you would probably want to provide some level of protection and access limits. So in this case, we support VPC to VPC as well as VNet to VNet, depending upon your other cloud environments. We also support subnet to subnet in the same VPC or VNet. So it can be fairly fine-grained controls, within your region environments. Notably, this carries the same capabilities as the ingress use case I mentioned, where it's stateful layer 4. We do include the metadata as your objects. I did mention the call out before, but we are working on also advanced rules. So for both ingress, whether it's internet or direct connect, as well as the east-west, we are working on advanced functions where you can do full break-in inspection on that traffic, the classic capabilities like app ID and intrusion prevention and so on and so forth, even data protection. So those will be coming up into the new calendar year. All right. Great. And here's the simple image. We'll keep kind of carrying that through. So there's the two VPCs. In this case, there's traffic between those two VPCs that need to be inspected. And your insertion point would be the same I mentioned before, where you're using the cloud native route, directing it to that service endpoint, and Zscaler is managing the infrastructure in that case. So you could protect between those VPCs. All right, let's move into the microsegmentation piece. And this is kind of tying in just the mapping on the upper right. So the example here would be you now have applications that are running within, say, the same VPC, the same subnet. We actually can support microsegmentation that spans across VPCs even farther. There's even cases where we have some customers doing microseg across clouds. So there's some really interesting kind of models that we're seeing. But the other thing I'll note is that microsegmentation is typically it's labeled as like crown jewel applications. I think I called that out in one of the slides. But crown jewel applications we understand as being the most sensitive. They're business critical, and so we tend to put a little bit more emphasis on the controls and the visibility for that traffic. We are seeing customers extend that definition, where crown jewel applications can be more than just say like tens and hundreds of applications, but even like thousands, tens of thousands, and there's some cases where we're seeing even more than that. So we're seeing kind of the expansion of being able to use host agents on many more VMs and EC2s, and as well as container environments that I'll talk about. So in this case, this is a new Zscaler host agent. We actually launched this earlier this year. This was in around February or so. This host agent runs in user space. I'll go technical just for a second here, but it's user space. It does provide optimization to your application. So we were intentional making sure that that host agent didn't absorb too much of the memory and CPU. So it actually programs the underlay's native firewall. So as you're building your rules, it's actually all stateful layer 4, 5-tuple. And we actually program the rules down into, say, Windows filtering platform, if it's a Windows system, or IP filters, if it's like a Linux system. So your interface is pretty simple, but then we're programming the underlay for that. Notably, we now support containers. So we now have EKS support, and then upcoming is other K8 type services from the other clouds. This does provide cluster and node level controls. So what's interesting about the integration here is that we are eBPF integrated. It's a very popular acronym these days, but it is eBPF based, so it's Kubernetes native. So that means you can deploy it very easily. You can maintain change control very easily. And our insertion point here is actually a daemon set. So daemon set basically acts as a host agent equivalent. But that will give you those cluster level, node-to-node types of controls. And it's also using the same mechanism. So you're also building those rules as if it's a VM or EC2. Now it can be applied to containers using those layer 4 stateful rules. This is also built both environments, whether it's a VM or it's using the containers. That's all built on IMDS. So you get all the metadata as part of your object definition. Notably, we do support on-prem, so we do support virtual machines like VMware, ESXi, as well as bare metal. So, and that actually is upcoming support with CMDB. So you can actually get metadata in both environments if you happen to be maintaining the on-prem as well. So one more thing I'll note here is that we have customers that need visibility. And so we do have a discovery service that's built into both the kind of macro environments as well as micro, meaning using the Zero Trust Gateway or Zscaler microsegmentation. We have this discovery service, so it gives you the full awareness of what's inside of your region. It's all region level, actually. So you deploy this region level service. You see all the VPCs in your environments, or VNets, depending upon your locations. We also help you discover the subnets. Also, all of the workloads inside of those environments, whether it's EC2s or VMs, containers, and we also give you all the metadata. So in your environment, you'll see all of that within your Zscaler portal. We do that actually, by the way, through both a polling mechanism as well as pub/sub. So you can enable that using like Event Bridge or Event Grid, depending upon your cloud environment. So that would give you almost like instant visibility. So as you're building a new EC2, as an example, you'll see that as fast in Zscaler portal as you would if you're in your AWS environment, because we're running on the same bus using the Event Bridge or Event Grid. One of the other areas we focus on is the flow analysis. So this is the actual traffic visibility. So if you've ever used microsegmentation, it's a lot to deal with because you're in the throes of all the traffic details. You're seeing those microflows. So we've made a concerted effort to extend the visibility to customers so they can have that level of situational awareness beyond just the workloads, but also their activity. So within Zscaler microsegmentation, as an example, we provide what's called a workload activity view. So as you deploy those host agents, you'll actually see all the different microflow activity, like coming in and out of your individual host, or at a group level. Typically, you'll build groups, and then also it can show you the traffic that's going to, say, unmanaged, like traffic that's hitting, say, a load balancer or something like that. So these are all important, so you have that awareness. And then once you move into policy definition, these lines effectively change colors. You can actually go in to see a policy map, and you'll actually see now that flow has a rule, and it's been enabled, and I'm good to go. So we've kind of helped customers with some of the easy buttons, so you can see what's happening, but then make those adjustments, make those policy decisions, and then you have that same view to start to kind of correlate and connect those things together. All right, now we'll come back to the example here. It'll just be a little bit of a rehash. I'll just break this out. And so circling back on this, there's a little bit of liberty I took on these use cases because the developer coming in, this could be an on-auth case. It's possible maybe you have a partner, maybe you enable, maybe not necessarily a dev and cognition use case, but maybe some other kind of application you can enable that ingress in using the gateway. But the left side with that developer would be also a traditional Zscaler use case. You have a Zscaler client connector, running on desktop, laptops, mobile, and you can enable that access to that location very, very specifically. And again, you're providing those zero trust principles. You're authenticating that user, you're identifying them, and then you're giving them a very specific location. So with like ZPA, as an example, that private application support, that could be all the way down to a tag. So your access policy for that developer is the very specific dev in front end in that case. The other cases here, this is now more incorporating in the gateway capability. So the Zero Trust Gateway would be protecting the traffic that needs to go out to public applications. So if you have those applications, or a couple examples there would say Git, then that would be hitting your internet. And so that's where you can apply fairly fine-grained controls using what we call ZIA, that internet access. And that would be layer 4 to layer 7, plus even data protection type rules to that use case. And that transaction could be bidirectionally, depends on how you're operating that, but that could be, say, using a direct connect path if it was certain types of applications back to a data center. So it just depends on what that public app location could be. It could be public-private. On the right side, as you go into private applications, that access would be, say, AWS. You're going out and you need to connect to your data center. Maybe it could be another cloud provider that you're leveraging. And so that could provide end-to-end connectivity using the cloud metadata to provide those very fine-grained controls for your access policy. And then the right side just captures the microseg use case where you can provide those the visibility and controls all the way down to those applications, all the way down to the VM or the container environments in the customer DB example. Cool. And then here's some of the details. These are actually specific to these customer cases. These customers are in production actually, and they're getting value out of these cases here, which is they're getting the prompt secure from the outside user. And there's also the API call support. I didn't note that, but that's also available, and also for your RAG information. So the augmented retrieval piece there. So that's all through these use cases. So this is kind of the roll-up of how the customers deploy, and then what value they're getting out of the Zscaler solution. Cool. All right. Yeah, and then just the last bit here. We're big fans of simplifying customers' environments. So we noted how to provide better protections, better security, how to help your networks transform a little bit, but also help reduce cost and some of the legacy components. We can help remove those, provide alternatives for those, and those are noted by the gateway. We've been helping customers move away from some of the traditional network firewall approaches and being more zero trust. And then some of the segmentation capabilities I mentioned, where with the east-west, you can now do between the VPCs and between the subnets, so that can provide some alternatives. Instead of using a dedicated firewall for those paths, you can actually consolidate that case. And then with microsegmentation, that provides the controls all the way down to process level. So when you're actually applying the host agent on the VMs or EC2s or the containers, the control is actually a process. You're actually blocking the process before it even goes in or leaves your given compute infrastructure. All right, so that, I kind of wrapped up early. How about that? I'll save you some time there. But we do have a booth. There's a lot of demos there. We've got a great team that's been here doing a lot of demos all week, and definitely dig into it. There's also a lot of AI components there. I didn't mention in the talk, but there is some new capabilities called AI Guard, and that's for prompt access coming in. We actually are launching a lot of AI capabilities in January 2026, and so just stay tuned for more of that. So you'll see a lot of new AI capabilities from Zscaler. But I think I'll wrap here, and I can take questions as well since we've got a little extra time. Otherwise, you've got a few minutes back to you guys. So appreciate the time.